This is a fan. Blow on it and it spins. Blow harder and it spins even faster. Congratulations! You have discovered that moving air creates thrust. So the clever you puts the fan inside a metal tube. As the fan spins, air shoots out the other end. You adds more fan stages for extra thrust. But instead of increasing, the thrust gets weaker. You soon find the problem. After passing the first blades, the airflow starts spinning and hits the next blades at the wrong angle. So the clever you adds fixed guide vanes to straighten the airflow, making each stage more efficient. But fan thrust alone is still not enough. So you add compressor blades that squeeze the air into a smaller space, raising its pressure and temperature. Next, you add a combustion chamber behind the compressor. Fuel injectors spray a fuel into the hot compressed air, where it ignites instantly. The temperature jumps above 1000 degrees. The hot gases rush out, creating powerful thrust. But there is one problem. The compressor is powered by an electric motor. Once the battery dies, the engine stops. So the clever you adds a turbine behind the combustion chamber. The hot exhaust spins the turbine, which drives the compressor through a long shaft. Now the exhaust spins the turbine drives the compressor, and the compressor keeps the engine running. Congratulations, you have invented the turbojet engine. But turbojets use too much fuel, so the clever you adds a huge fan at the front, much wider than the engine itself. Some air goes through the engine core, while the rest flows around it through a bypass duct. The fan now has two sections. One pushes bypass air, while the other compresses air for the engine core. The bypass air provides most of the thrust, while the engine core provides the rest. The two streams combine at the exhaust, creating an engine with more thrust, lower fuel use, and less noise. Congratulations! You have invented the turbofan engine.